Welcome to this brief introduction to Autowarp, a new method for learning a distance metric from unlabeled time series data. Well, time series data are everywhere, from medicine to web analytics, and the question that motivated Autowarp is what you do when you have lots of unlabeled time series data. Is it possible from the time series data alone to learn a good similarity metric that allows you to say, hey, this trajectory is most similar to this other trajectory? The key challenge here is that time series data can have very complex sources of noise, such as different sampling rates, outliers, shifts. So we propose Autowarp as a method to robustly learn a good similarity metric. There are two key ingredients to Autowarp. First, we recognize from other domains such as image analysis that autoencoders are good at discovering relevant latent representations. So what happens when you take a time series dataset and feed it into a sequence-to-sequence autoencoder? Is it possible to use the learned latent representations to capture the key essential characteristic of each time series and ignore some of this complex noise in the time series data? Well, we did an experiment to find out. We took trajectories from 5 different classes, represented by the different colors here, and we embedded the trajectories in 2 dimensions to see if the time series data would cluster according to what class they came from. It turns out they don't, and that's because the time series data have very complex noise in them. But if instead you cluster or you embed the learned latent representations, it turns out that the trajectories belonging to the different classes do cluster a little bit better than the original trajectories. However, the results are far from perfect. You can see different classes of trajectories mixing together. So the key second ingredient is that we regularize the learning process with a family of sensible metrics known as warping distances. Now, warping distances include many of the distances that you're familiar with, including Euclidean distance, dynamic time warping, edit distance, and so on. Now, this helps a lot. When we regularize in this manner, the learned warping distance allows us to completely resolve the trajectories into the original classes that the trajectories come from. Now, this works not only on synthetic data, but also on real data. This was a very exciting result where we showed that on this data set, Autowarp not only outperforms many off-the-shelf distances such as dynamic time warping and edit distance, but also it outperforms SSPD, which was a distance that was handcrafted for this particular data set. So the key takeaway here is that with Autowarp, you're able to avoid using off-the-shelf distances or even having to handcraft your own distance, and you can learn a good distance metric from your unlabeled time series data that works well for your unlabeled time series data. Check out our NIPS paper for more information.